Hi everyone, welcome to the 62nd session of Python for Machine Learning. In this session, we will learn about multivariate linear regression. As we have already learned what is a simple linear regression, in simple linear regression, we have one input and one out. Suppose this is my x-axis and this is my y-axis. So here we are dealing with two dimensions, x and y. This is x-axis and this is y-axis, and we have all our distribution of the element here, all of the distribution there. But in case where we have n number of distributions, like we have more than two columns, we move to a three dimensions where the number of columns is three. But again, when we work with the data set, the number of columns is not confined to two or three, it can be n number of columns. So that's when the multivariate linear regression comes into picture. So when we deal with the simple linear regression with a one input variable and one output variable, our equation is something like y is equals to mx plus c, where m is my slope and c is the y-intercept. Now, in case where we have n number of columns, in that case, my out equation will be something like y is equal to b0 x0 plus b1 x1 plus b2 x2 plus b3 x3 plus dot 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 plus bn xn. Now, in this case, we assume x0 to be 1. So our final equation will be something like y is equal to b0 plus, it will be like you add here all these things. So this will be my final equation. Now we will work in this session. What are we going to cover? We are going to cover, first of all, the step-by-step approach we'll follow, and so that it will be very easy to understand what we actually trying to achieve in this session. First of all, as usual, we'll import the pandas and numpy and the seaborn and the matplotlib, everything. And then in the next step, we will we'll check in the first step itself, we'll check whether there is null values or not. Next step, we will plot using the seaborn pair plot function, which is called pair plot, which will be used to see whether there is any outliers or not. And again, we will see what is the distribution of my different relationship between different variables. Once that is done, then we'll move to the seaborn heat map. From there, we will get the correlation value, which will vary between -1 to +1, and I'll explain it further when we reach there. After that, we'll extract the features and level, and then we'll do the train test split from cross validation. After that, we'll create a linear model. Then we will interpret the coefficients and intercept of the model which we create. After that, we'll predict the output, and then we also predict the accuracy score, means percentage. What is my score of this model? Then after that, will verify whether my model, whatever I have predicted, the value, how it is being formed, how it is being calculated at the back end of the algorithms. After that, then we will calculate the mean squared error and the root mean squared error, which is going to tell us how is my model performing. Okay, so let's start. We will start with a taxi data set, taxi.csv, where we have these columns like price per week, population of city, monthly incomes of the rider, and then average parking rates per month and the number of weekly riders. So suppose like we have the first step will execute step number 1, which is like importing the necessary libraries and the data set. So we'll execute this. So our data set is formed. If we see df dot head, then we have this value, which is the price per week of this. Then the population of these, all these records belongs to the different cities. Okay, and then we have the monthly income of the drivers, then number of weekly riders, we have the average parking per month, and all these values we have. Okay, then we will also see whether we have any null. df.info, any null values we need to check, which is the most important thing. So it's a pretty small data set, and we don't have any null value. So once that is done, we will. Okay, so the next step is step number 2, which is nothing but plotting the seaborn pair plot. So how that works, we'll give SNS is nothing but an object of seaborn pair plot, PAIR PLOT, and then we'll give the name of a data set is DF. Okay, we'll simply execute this. So if you see from this figure which is generated, you can see that all the different field you can get the correlation between each and how they are correlated, whether they are negatively correlated or they are positively correlated. If you see this price per week with number of weekly riders, it is negatively correlated, whereas average parking per month with price per week, it is positively correlated. And everything you can see, we don't see any point which is lying like extreme of this distribution. So since this data set is small and like we have limited fields, so this is quite fine. I don't see any outliers. Even this is not a big outlier. Like we can I have already created a session where a video where I've shown the outlier detection and outliers. So in this case I don't see any much outlier here. So we are fine with the we don't need to do any outlier detections as of now. So after this, what we'll do, we need to execute the step number 3, create the heat map. So heat map, what it will do, it will show you the values of the correlation between each and every field. What is the correlation in mathematically? df dot correlation followed by, we have to make it, it should look good. Line width is equals to 0.2 followed by max. These are the parameters. Then we need to form a square which is equal to true. Then color is equals to suppose red, and the last parameter annotation is equals to true. If I execute this, okay, now this is like what I was referring to the heat map. In this you can see the value is ranging from -1 to +1. Okay, see this is 0.97, this is 9 minus 1. So the number of weekly riders and price per weeks are strongly correlated. And if you see here, most of the values is like around +1 or -1. So we are pretty fine with the distribution and also with the correlation of the field. If any field which is lies around 0, we don't consider those fields. We can drop those fields. So it depends upon the what is your root mean, what is the output of your model. So those things will decide. So this will come into picture in the later part of the analysis. So but before doing creating your model, we should evaluate this heat map, and we should get the correlation between each and every field. So after this, what we need to do is we need to extract the features and labels. Okay, if you say this data frame, we are supposed to predict the number of weekly riders here. So our features is column 0, 1, 2, 3, and our label is column 4. So how I will write this, features is equals to df dot ilog colon comma 0 colon -1 dot values, and labels will be df dot ilog colon comma -1 dot values. We'll execute these two lines. Okay, so if you type features, so you can see the features formed correctly, and labels also will be is formed correctly. So step 4 is also completed. Then we move to step number 5. So what is step number 5? Step number 5 is nothing but a cross validation, where we need to do the train test split. So in this case, we need to simply give from scalar dot cross validation import train test split, and after that we need to give as train comma x test comma y underscore train comma y underscore test is equals to train test split. We need to pass the features, labels, then test size, which is equal to, in this case we are giving 0.3, and random state is equals to 0. I've already explained about random test and test size and this entire sampling concept in my previous session. And then we'll execute this. So our cross validation step is completed. The next step will execute is the linear. We'll need to create the linear model. So for this we have to give from scalar dot linear model import linear regression, and then we need to create a object of linear regression. Once this object is created, we need to fit it. will execute this. So my linear regression model is also completed. Now I need to simply do a prediction, okay, which is my step number 7. How to do ypred, which is nothing but regressor dot predict, and for which value I will predict uh, x underscore test. Okay, so if I predict this, I'll get some value ypred. I'll go here. Okay, ypred is here. Then we'll get y test also. So if you see, we have predicted the value as 1 for this record as 188630, and this is quite nearby, though it's not very close, but it's quite close. Okay, so this is how we do the prediction. After the prediction is done, we need to interpret the coefficient and the intercept. So how do we do that? It will be step number 8. So if you want to print the regressor, we have to type here as print regressor dot coef, and if you want to print the intercept, print regressor dot intercept. So intercept will be nothing but your b0, whereas coefficient will be nothing but it will be your b1 b2 till your number of columns. So we'll execute this too and we'll get the value here. So we can see the value which is being printed here. Okay, now if you want to proceed further, the next step is predicting the output. Okay, we have already executed this predicting the output before this interpreting the coefficient. Now next step is predicting the score or the accuracy. Accuracy under score comes under the case of classification. In case of linear regression, we use score. So print test score is regressor dot. Okay, so now we'll execute this to while train. So we have the accuracy score for test. Actually, this is opposite. Extremely sorry for this. No, it will be fine. So for train it's 94%, and whereas for test it's 91%. So if you want to increase the accuracy, this regression score, you can go and change the, like you can do, there are several steps which you can follow. You can get the correlation, you can get the variance of a different columns, and you can remove that based on the value for which is very low. Now the next step which we are going to follow is the verification of the predicted values. How do we achieve this? What I mean is the value which we have got here. How do we verify whether this value which we have got here is correct or not? For this, so what we'll get, this ypred is nothing but the output of x test. So what is x test? X test is this value. Okay. So what we will do for this 0th row, so this is nothing but if you go above, we'll follow this equation only, b0 x0. So what is my intercept? So what is my intercept? This is nothing but regressor dot intercept plus. Now if you see here, the slope is nothing but b0 for first column. So regressor dot coefficient y is equal to b0 plus, so b0 is nothing but regressor dot intercept. Then b1 is like regressor dot coefficient, which is like the first element in that list, followed by the my x1, which is the if you see this x test, this value 15, so that will be nothing but x test 0 0. So if I type here x test 0 0, I'll get that. Okay, I'll get that value 15. Okay, similarly we'll go for the rest of the column, and if we evaluate this value here, we'll get the value of y output as 188629, and y pred is, what is the value of y pred? Y pred is 188630. So this value is being rounded off, and we have got here y this value. Okay, now if you want to calculate for the second record, okay, for the second record it will be something like y output 1, and then for the second coefficient will be the same, but here it will be first row. For every excess it will become first row. If you, so y output is this, and y pred, if you see, where is my y pred? No, not this one. This is my y pred. So my y pred is the second element value of y pred 136559, and here also is 136559. Now this 9 will round this to 4, and 4 will not be able to round this 9 to 10. So it will, the decimal portion will be cut off, and then like will removed, and this value will be finally 136559. So we have shown how we can like verify the value whatever we have generated is correct or not, and which is coming absolutely correct after the evaluation. Now the last step is nothing but the calculating the mean squared error and the root mean squared error, which is like, how do we calculate this? The root the mean squared error is nothing but when we draw this, when this line is created. Okay, this is my actual value and this is my predicted value. So the difference of this value will take a square, and we'll do this square for the entire point present in this graph, and we'll take a sum of that. So that will be my, suppose the sum of is x, sum is x1, some point will be here, sum of the square is x2. So we'll do x1 plus x2, which is nothing but a square, and similarly we will go for all the point, and root mean square will be nothing but the square root of this whatever value we get here, it will be the square root of that. So we'll calculate the mean squared error using scalar. So for this we will do from scalar import matrix, and then we'll print matrix dot mean squared error y test, comma y test and y pred. We'll find the difference. Okay. And then after this we'll find the mean squared error between the root mean squared error. We'll find the root mean squared error, which is nothing but np dot sqrt, and inside that we'll paste exactly this values. So this is my MSC mean squared error and the root mean squared error of this model. Now, suppose you have been asked, this is like I have not planned as per my like this step. I have not planned, but will calculate one. I'll show one more thing, and then the session I'll wind off this session. Now, suppose I want to calculate something which is not present in this x test. X test is, or x train, whatever. I'll create something called x1, which is equals to this is, what is this value at basically, price per week. So price per week I'll give 80, followed by the population of the city. I'll give 1,70,000. I'll give 17 lakhs. Okay, 700, something like this. Okay, followed by monthly income of the rider. I'll give 6,000 and average parking rate per month I'll give somewhere around 85, and then let's execute this. So my x1 is created. If I want to predict what will be my output, and what is the output be the number of weekly riders, how will we predict? We will simply go out1, which is nothing but output, which is regressor dot predict, and we'll give x1. So out1 is how much? 153. The value is 153488 is the number of weekly riders. So this is log, and if you have more than one items to be predicted, you can have this in your Excel sheet or in your .csv file, and you can import it in the similar step, and you can do like just instead of this x1 you pass those features. Okay, so in this session what we have learned what is multivariate linear regression. Then we have learned how to use Seaborn pair plot to find whether there is outliers and what is the correlation between the variables. Then using the heat map, we have seen that the values of the fields lies around -1 and +1 and not around 0, so which is fine. If it is 0, we need to think like after we create the model we can think of evaluating eradicating or removing those fields. Then we have using cross validation, the train test split, we have done the segregation followed by creating the linear model and then predicting the output as well as interpreting the coefficient and the intercept. After that we have predicted the score, and also we have manually we have calculated and done the verification of the predicted value, which is 100% like matching with whatever we have predicted. And then we have calculated the mean square error and the root mean squared error using the sklearn library, the metrics function from that we have used. And after that I have shown one extra point like how to predict the value which is not present in my training data set or in the testing data set. Okay, basically in my train data set. So thanks a lot for watching the session. If you feel this video is helpful, please press the like button and also subscribe to this channel. I'll see you in the next video. Thank you.